Hello, my friends. Screencast number 4, Consumer and Producer Surplus. This is kind of like a side note to the last screencast, some other things we have to say about equilibrium and some of the things we can see in equilibrium and some of the reasons why I love equilibrium oh so very much. Alright, we're talking about something called welfare analysis here. Now, both consumers and producers expect to gain from voluntary exchange. Every time you go and buy something, you're expecting to gain from it. If you buy whatever, I don't know, a scooter. I just bought my daughter a scooter for whatever, $50. What you're saying is you expect to receive at least $50 worth of benefit out of that scooter, and maybe even more, right? The fact that you're just paying $50 doesn't mean it's worth $50 to you. Maybe it's worth 60 or 100. That extra money that you'd be willing to pay, but you don't have to pay, is a gain to you. Same thing with producers. If the producer is selling the scooter for $50, it's worth something less than the producer to sell it for that. Otherwise, he wouldn't be selling it for 50, or she. So total welfare, think utility, utils, is a measure of those gains. Now, competitive market equilibrium provides the greatest amount possible of combined welfare. It's one of the reasons we like equilibrium so much. In other words, equilibrium leads to the most possible happiness for consumers and for producers. The amount of those gains can actually be graphed out and calculated numerically. So let's start off with what's called consumer surplus. Let's say you walk into a coffee shop and you expect to pay $5 for a latte. In fact, you'd be happy to pay $5 for a latte. You really want a latte. You walk in and you find out that today lattes are on sale for $3. How do you feel? Well, if you're feeling pretty happy, I'm going to ask you a slightly more difficult question. How happy do you feel? Well, I'm going to suggest that you feel at least $2 worth of happiness there, right? You were willing to pay $5. You only had to pay $3. It's as if you actually did pay $5 and someone just walked up to you and handed you $2 that you weren't expecting. However happy $2 would make you, that's how much happiness you're experiencing. And that's what we're going to call consumer surplus. It's the happiness that resides in your head because you don't have to pay as much for something as you were willing to pay for it. So we're going to define consumer surplus as the difference between the price that consumers are willing to pay and the price that they actually have to pay. Now graphically, that's going to be the area between the demand curve, because you'll remember the demand curve represents willingness to pay, right? Every price for every quantity that consumers were willing to pay, and P star, equilibrium price, represented the actual price or what consumers had to pay. So consumer surplus graphically is the area between the demand curve and P star, or specifically the area below the demand curve, above P star, for all the units that are actually purchased, for all the quantities from a quantity of 0 through Q star. So if we had a graph that looked like this, we'd find consumer surplus again by looking at the area below the demand curve, here's the demand curve, above P star, here's P star, from 0 to Q star. In essence, this triangle right here represents consumer surplus. Think about it. For the very first unit, this demand curve is saying that somebody is willing to pay $5. The price that they actually have to pay is only $3. So for that first unit, there's $2 worth of consumer surplus there. For the second unit, someone's willing to pay about $4.20. They only have to pay $3. So for that second unit, there's consumer surplus of $1.20. And if you do that for every unit involved, you'll get something that looks like a triangle. In fact, it'll look something like this. If we had a graph that had numbers on it, like this graph, we could actually calculate the amount of consumer surplus by using something you'd never thought you'd ever use in your entire life, the formula for the area of a triangle, which I'll remind you is 1/2 times the base times the height. So here we have 1/2 times the base. Here the base is 500. From a quantity of 0 to a quantity of 500, there's the base, times the height, price of $5 to a price of $10. In this example, we have consumer surplus of $1,250. An extra $1,250 worth of happiness residing in consumers' heads because they don't have to all pay the equilibrium price. A lot of them are willing to pay more. Producer surplus is going to be the flip side of consumer surplus. Let's say you're selling lemonade, and why I use lemonade as an example so often I don't know, I apologize for it in advance because I'll probably use it again. You're selling lemonade at $1 a cup. Let's say someone walks up to your lemonade stand and just offers you $7 for a cup of lemonade. Again, how do you feel? Pretty happy, right? Well, how happy? Well, it's as if you actually sold that cup of lemonade for $1, and then someone walked up to you and just handed you an extra $6. You're happy. However happy $6 extra would make you, that's how much happier you are in your head. That's producer surplus. So we're going to define producer surplus as the difference between the price producers are willing to charge and the price that they actually do charge. Graphically, it's the area between the supply curve because that's what represented what producers are willing to charge for various quantities, and P star, which is the price, the equilibrium price that they actually get to charge. Specifically, we're looking for the area above the supply curve, below P star, again for all the units that are actually bought and sold, from a quantity of 0 through a quantity of Q star. So again, if we're looking at a graph, what we're looking for is this area. The area above the supply curve here, whoops. The area above the supply curve, below price, from a quantity of 0 all the way through a quantity of Q star. In other words, this triangle here represents producer surplus. And again, if we had a graph with numbers on it, we can calculate the actual amount. Again, being the area of a triangle. 1/2 times the base times the height. Here's 1/2 times the base, which in this example is again 500, times the height, which in this example is 5, or $1,250 worth of producer surplus. Now in this example, consumer and producer surplus were exactly the same because the graph was symmetrical, but it doesn't always have to be that way. Now one other thing I should mention, a very scary, spooky term called deadweight loss. We define this as the loss of consumer or producer surplus, and it could happen for any number of reasons. It usually happens when the market's not allocatively efficient. Remember what that means, producing the perfect right amount of stuff, producing at equilibrium essentially. If we don't let the market go to equilibrium, we're going to be losing out on a piece of that producer or consumer surplus. So in the same exact graph, let's say the government were to come along, just to give one example, and limit the quantity produced and sold to 300. If that were the case, we'd essentially be cutting off part of that consumer and producer surplus. The yellow triangle that you see is all of the producer and consumer surplus that's lost if we don't let the market go to equilibrium. If the government cuts it off, or for some other reason, we get a quantity that doesn't represent the allocatively efficient quantity. I think of that as babies crying or suffering. It's basically the sucking out of happiness out of humans' heads, which is bad because there's not enough happiness to go around in the first place. We call that deadweight loss. And we're going to be using the concepts of producer and consumer surplus to look at different kinds of markets, because what we're going to be looking for is lots of this stuff. And if we don't see lots of this stuff, we're going to have a problem with that kind of market. All right, that's it for this one. See you next time.
Oh my God!